let me start with continuous integration. This should be called not integration, pretty much continuous, because you can do with Puppet integration, deployment, and even validation if you want. Let me just go through it. I hope that as intermediate, don't think that you're going to see a lot of code, because it's not. It's more a little bit of, I wasn't sure like if it was all beginners, not beginners, or what, so I'm actually get a little bit of high level of everything. Really quick, before we start, how many here are on ops or operations? How many here are developers? How many here are managers and above?
I'm a developer who's a build engineer.
Okay, that works. Don't worry. So first of all, who am I? I've been using Puppet since version 0.22.2. That's a long, long way time ago, like years back, around 2007. So I've been through Puppet all from its up and downs, good and pros, and cons and everything. Those are some of the companies that I've worked for in the past, and some of the places where I've been giving talks. OpenStack lately, a lot of people going into the cloud. That's another question, who's into cloud already? And how many of you are actually type of DevOps? Okay. Okay, so let me just, I hope I'm not gonna confuse you much in the way that I'm actually gonna go through things. So the agenda is gonna be continuous integration or continuous deployment or whatever you wanna call continuous. How Puppet can help on the continuous integration deployment environment. Puppet environments equals to CI environments. Then we're going to talk a little bit of package, test, deploy, how to use infrastructure as code on pretty much the end result of using Puppet inside of CI, question and answers. So let's start. Continuous integration, pretty much everybody knows about it. This is how it usually works, that you have your build server or continuous integration, call it whatever you want to call it. Then you have your source control management, where developers go over, put some code into it, and then the continuous integration grabs, builds whatever it is, and then you just pretty much push it over to stage, production, or whatever. This thing works pretty well. The only problem comes when you want to scale. When you want to scale, and I'm not saying 100 servers, I'm saying a few thousand servers, it's really difficult to manage everything. Why? Because you start seeing difference between environments. Let's say I have your dev environment, which is different from your stage environment, which is different from your production environment. And I'm not saying that it's different from the application layer, it's different from the infrastructure part. You go over and say, okay, I have my dev environment here in my laptop. Then you have your stage environment in the middle of nowhere, sitting in some data center. And then your production environment in some PCI data center. It's even more restricted. So a lot of those problems comes within continuous integration because you're going to end up saying, okay, why the hell did it work in development and it's not working in production? So here's where Puppet comes into place. And actually, it's pretty much Puppet and any type of virtualization that will help you out though. So how can Puppet use CI? First of all, automate the configuration of the infrastructure. You write it once to deploy it everywhere. Doesn't matter where it is, you just deploy it. Automate your package deployment. You can pretty much configure Puppet, or actually the build server, to tell the Puppet master to pull down a specific branch, and then on that branch specifies like your new version of the S, Y, or Z commit that you put on your SCM. That gets deployed, you have continuous deployment right away. Keep tracks of the changes done on the infra layer. We already saw a bunch of talks about it. The easiest way to keep track of how to do things, just put it on an SCM or your Puppet code. That will basically grab and say, okay, you know what, this guy pushed this change into it. Of course, there's a lot of tools that will make it easier for you, but if you don't have anything, I mean, better than, at least that is better than nothing. Then, basically, it will allow you to control where and how you're going to deploy your software. Meaning that by using your build server as an orchestrator for pushing your code, and we'll see a little bit later, you will see that it's way much more simpler to go over and say, okay, build server, deploy this version of the Puppet code or this commit of the Puppet code, and you just let it run. We'll go through a little bit more. It will make more sense once we see the environments. And last and for all, you stop using the build server as a guy that will basically go over and do groceries for you. that you're going over and telling, okay, deploy this stuff and rebuild this stuff. No, basically just compile, build packages. It's a build server that is, and that's the only thing that you should work with. So, oh, there we go. So the Puppet environments equals to CI environments. What am I actually saying about this? First of all, you know that Puppet can control multiple environments. The way that it's easier for everybody to go over and just deploy, and a lot of this has to do with the R10K that they just talked about a little bit. PuppetConf, they basically introduced that thing, and basically allows you to control the environments in an easy way. Why I'm saying that Puppet environments equal to CI environments? Because you should go over and say, okay, this is going to be my Puppet code. I'm going to push it over into a branch that I'm going to call development. And then you call that branch exactly a development environment in Puppet. You have the same deal with your stage environment, which is basically the only difference between the development environment and the stage environment is that your development environment, everybody commits into it. The stage environment gets promoted or actually merged once your build server or your test framework actually validates that everything that's done with Puppet is actually correct. And last and for all, you have the production environment, the final end target, which is going to get all the merges from your Puppet code that is on SCM once you're ready under your, I don't know, downtime window or your change management, or if you're agile, you just go ahead and just keep deploying. So that's the reason why I'm saying. Why? Because there's a lot of ways of doing things with Puppet. There's the Puppet master way, there's the Puppet masterless way, which basically you take off the Puppet master at all and you just use Puppet apply run, and you pretty much orchestrate it in some other way. It's a good thing. You can actually make it able to scale way faster than a Puppet master. Scaling a Puppet master is a little bit more difficult in the sense that you'll have to put a bunch of, the Puppet master becomes an application, a web application. So you can scale it in the same way that you scale a web application. Put in proxies on top of it, put in a cache layer, put in a bunch of web clusters in the backend. Anyway, that's another talk. With these environments, you can pretty much keep track of whatever is going or the users are actually doing in development that is going to be exactly the same thing that is going to go and end up into production. It doesn't matter if it is just application code or if it is actually infrastructure as code. I'll talk a little bit more about that later on. And then, so we already went into like drop your Puppeted code into SCM, create the 3 branches or your 3 different, not even the branches, you can create 3 different repositories and just pretty much just keep merging one on top of the other when you actually are getting ready to push the changes into different environments. And let your Puppet master go ahead and pull from those branches. I don't know how much you want it, every 5 minutes, every 2 minutes. It depends on it depends on your Puppet master server, how fast you want it or how you want to control your cron job, doesn't matter. The whole point is that at that moment you have your Puppet master pulling everything from SCM. The benefit of it is that you control through SCM how things are getting pushed into the Puppet master. So the Puppet master becomes just a relay agent saying, okay, I'm waiting for new code, I'm waiting for new code, I'm waiting for new code. When you decide to push it over into SCM, the build server reads everything or does tests or whatever. I'm going to go through that after in a few seconds. Then the Puppet master will pull it, and in that exact moment, it will actually go over and tell their nodes, you know what, you have to do all this stuff. So you're moving all the, you know what, you have to check your Puppet code from the Puppet master itself into a previous or like in your continuous integration step. So let's keep talking. I'll go through an example a little bit later. Package, test, and deploy. This is another thing that Puppet will help you out a lot inside of the CI. First of all, your software, whether if it is Windows, Linux, whatever, use packages, please. Puppet will make your life easier if you just go over and put everything into a Debian file, RPM file, or anything else. Use as much as possible the package resources from Puppet. Don't go over and do these kind of things. This stuff from here, no. It's way much more difficult to go over and see why you actually failed than going over and saying, you know what, the package failed because, I don't know, it's lost in the repository, rather than, oh, by the way, I forgot to change the permissions into something else. And if I go over and deploy the war directly. So the other thing, define standard sequential numeric version convention for your code and for your packages and for everything. If you go over and do pretty much a standard, and let's say this in this example, version 0.xxx, that's all my development branch. That's pretty much all the packages that are going to come out from my build server for development. So you know that the next time somebody goes over and puts another commit into it, it will generate a new package of that commit. We'll go ahead and say, okay, deploy it right away, no problem at all. If you want to go over and spend for everything else, use your like version 1, 2, version 1.1, whatever it is. Don't mix letters. Please don't mix letters into your names into the standard naming convention. Why? Simple reason. If you're using Linux, I'm not sure if Windows, I'm not pretty much a Windows guy, but if you're using Linux, this one will be understood by the jump packager, by the APT, aptitude, whatever you're using. If you put an A in there, pretty much it will go over and say, okay, I have version 1.22a. And then I have version 1.22. Oh, by the way, the A, I'm going to swap it over into the ASCII code. It means that it's bigger than 122, even though A means alpha. So you end up deploying alpha on top of whatever it was production. So please don't put any numbers in there. And the other thing that I'm going to go over there is the way that you write your Puppet code. And this has to do a lot with the test part that I'm going to talk about in a second. Write your modules in a recursive way. What I'm talking about here is that use requires as much as you can. Puppet has this option of saying, okay, you know what, this resource is going to have a requirement of this other resource within the resources. So as you can go over and see here, right now I'm calling the class. Let's just go over and say this is required repo. What it means is that when the node goes over and says, I'm going to install my package, we'll come here first and say, okay, in order to deploy my package, I need the repo first. So I'm going to go over to the class repo, execute this one, then come back, execute this one, and then, okay, I'm done. That's going to allow you to have Puppet runs instead of waiting 5, 10 minutes, 3, 4 times, 10 times to actually just go through all the Puppet classes and deploy all the resources. That's going to give you a run of probably 1 minute. And in 1 minute, depending on how fast you actually pull packages, set up resources and everything, you'll end up having from 0 all the way to application in just one run. You don't have to worry about, oh, I need to wait until Puppet goes over and runs again because some resource failed in the first run that it wasn't available at that time, and then I need to wait until it comes again and tries to push that resource and then go ahead and just keep going with the catalog. So always use, try to code your Puppet data into like a recursive way. The other thing, when you go ahead and test and deploy, first of all, on the recursive way, like I said, it's only one run and that will take care of it. On the test environment, let's say I'm going to go over and I'm going to push my Puppet code into SCM, and then simple Jenkins will pull that from SCM, and I'm going to go ahead and say, okay, I need to test it over. The test, like we already talked a few minutes ago, the no-op, besides of simulating, it also gives back an exit code saying, okay, I'm going to have, I think, 0 if everything went well, and actually I could simulate everything, or I'm going to give like a 3 or 6, I don't even remember, if there was some error. The same error that we saw before, that you could actually see, okay, I'm going to do all this kind of stuff, and there was an error in there because it couldn't actually grab it, because you need to define a user first, or you need to install a package first, or whatever. That will actually come up on your build server as an exit error code. So that at that point, your build server is going to go over and say, you know what, your Puppet code, even though I can actually execute it, is not logically correct, because I'm still missing something that is not going to go over and let me run everything completely. So in other words, the build server is making sure that your Puppet code won't crash during pretty much the apply execution. So moving that aside, We talk about the package, we talk about the test, now the deploy. So infrastructure as code. What is infrastructure as code? Pretty much Puppet controlling all your infrastructure. What's the main difference between ops and developers? The main difference is that, and this pretty much not only in like small places, in huge companies also the same problem. They see ops as in, you know what, you're an expense that I'm actually having, and the developers are the ones actually creating the product that are providing money to the company. In this case, if you go in as infrastructure as code, your ops team becomes another developer team. They won't be seen as somebody you have to deal with it to get your stuff. They won't go around and say, you know what, you're just ops, you have to do whatever I'm telling you. You can actually move from the ops way into, okay, we're now another development team. The only difference is that we're developing infrastructure. Doesn't even matter. I mean, Puppet is basically doing all the ops actions and all the automation for us, but at the end, we're basically coding what we go, what we're, the end result. So that opens the, kind of like the door for a lot of companies to jump into DevOps mode. What's the DevOps mode? Usually, developer actually doing ops or an ops doing development. Like I mentioned it before, by making it infra or your ops team another product, they jump to the development field. By the same time, the developers will be able to go and say, you know what, you're right, I don't have to know what exactly Linux is doing in the backend, I just need to know how to code Puppet. And then I can just jump into ops and do the things myself. So that will basically give you a little bit more of standardization between it and remove all those huge gaps that are between different departments in the same IT space, which I'm not even sure why they are in there in the first place. Anyway, once you're coding everything as, once your infrastructure is getting set up as code, it means that you can start adding features or bug fixes. Let's say you're gonna roll out something like a kernel update for 100 machines. That pretty much is, instead of going over and saying, ops has to go over and update everything and I'm gonna go over and push something into it and we're gonna have downtime and blah, 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 blah. You're gonna start to work it out in a way that the people will see it, okay, you know what? This is a patch that needs to be pushed into the system. The same way that you developers, and I'm a developer also, I'm just saying you in general, the same way that you guys generate a downtime window because you're pushing a bug fix on the application because the user, the end user is not able to do, I don't know, something fancy on the web UI. The same treatment I'm doing it, but with the infra. If you actually go ahead, the only difference that you are the developers and somehow are the customers of the infrastructure team. But at the end, it's pretty much the same process. So that will give you the option to jump to the next point. Infra can align to the software development lifecycle. Why is it that? Because you're going to have both of them actually working ahead, and they can pretty much set up everything into the same Scrum itself. The only difference that changes is what you're coding and what they're coding, but at the end, everything is code. It's not seen anymore as you have to go over and build servers, you have to go over and do something. Everything is code. And first and last and for all, deploy to 1,000 of servers, which in my experience, the most amount of servers that I've deployed a change in Puppet was on Electronic Arts, and those were around 7,000 at a time. And we didn't even care. The only thing that we did and that we actually care about was, okay, is the downtime window that we need to go over and do. Since everything's being checked by the build server, that Puppet runs properly and is actually putting everything in place I mean, we have all the logic properly set up. We can just go ahead and say, okay, git merge from our staging environment into production during the downtime window and let it go. We don't care about anything else. Why? Because we already tested in development, and then that was actually tested in production in test or in staging or whatever for actually benchmarking it, and then pushing it over as long as at the same time as the rest of the bug fixes for the applications. So this is your pretty much really basic view on how it would actually end up. The first one, let me just go back to the other one first. This is the way that you had it before. The continuous integration was actually doing everything for it. It was doing groceries, it was going over and hanging out with you at the bar, it was doing everything. This is how it looks now. The build server, the continuous integration server, basically is just doing packages and telling the Puppet Master, okay, you're good to pull down X, Y, or Z commit. Or you're good to go over and say, if you have Puppet Master or P or something or M Collective, just go over and tell it, deploy this stuff over there. I don't care how you do it, Puppet basically will take care of deploying everything. And Puppet's going over and telling your environment, okay, and not only that, this is just going to be something that I'm going to throw out for the PE guys. Is Puppet Enterprise still giving the cloud provisioners? Yeah? Okay. So cloud provisioners is pretty much Puppet talking to AWS, talking to VMware, talking to, I think, OpenStack. I don't remember how many cloud provisioners you guys have. But it will basically allow you to spin up a VM and kickstart Puppet with it. So if you have that option, you're telling the build server, go ahead and deploy my development environment. Go over and deploy my test environment. Go over and deploy my prod environment. Not only from the point of, okay, I'm going to go ahead and deploy my packages, my updates, whatever. No, I literally go over and build the VMs and wait for it. They go ahead and just push everything into the VMs, and I have my development environment up and running. So this diagram comes something like this. Developers submit application to the SCM. Ops submit infrastructure code to the SCM. The build server pulls the application call, compiles it, creates the package, and puts it on this repository. Now, it doesn't matter what it is. It could be whatever repository. It could be just a web server. Yeah, it pretty much doesn't matter. The build server pulls down the infrastructure code, parses it. Puppet has this magic, and thank God it has it, option that is called parse. You can go and tell it, I have my manifest here, Puppet, parse, and your manifest. It will basically check syntax code. It will give you if you have any problems or any errors or anything in there before you actually commit it into the SCM. Or after you commit it into the SCM, doesn't matter. But it will actually help you a lot into like, oh my God, by some X, Y, or Z reason, it's saying, oh, you know what, syntax error, and it doesn't actually say where. Or the developer, if you have DevOps already, will come back and say, I don't know why it's erroring. And it's just like, dude, you just have to read the error. What's the problem? Anyway, that will actually help you out a lot. And the other thing, the simulate thing, the no-op. So you already checked your Puppet code with parser for syntax error. You check the no-op to simulate it, and you can say that it's, I don't know, logical, semantics, whatever you want to call it. But if you actually make the build server to check for simulations, you will see and you will make sure that when it goes to the actual server, it will run, and it will run without any problems. Why I'm saying this? Simulates will try to figure out all the dependencies within Puppet to go over and say, I have this resource that is a package, I have this file that is another thing, I have this user, how they relate. They can go over and deploy first the user, then the package, and then the configuration file. That's pretty much something you'll see when you run no-op, like right away going after and after and after and after, and you'll see the actual dependencies saying, okay, I'm trying to install this resource, but wait, I need to install this other ones. Then I'm going to grab those resources, I'm going to install it, and then I'm actually going to try to install the previous resource, or execute or apply the previous resource. Once you have that one, the build service instructs the Puppet Master, like I said, to pull a specific tag or commit or whatever you want to use in there, or a branch, into the target environment. That means that if you're using Git, I'm going to Git pull into that specific tag.
The question that's coming, is this all have a fundamental assumption that you have one target, one application to deploy? Like, I've got 25 applications on the same box.
This on the same box, or
25 small services, all built by different teams.
No, that's pretty much up to how you want to organize everything. You know, the most amount of applications that I've deployed with this one was probably around 100. In multiple things, but there were some of them that were running the same service or one machine into multiple things.
Right, and when you do continuous integration, one of the metrics the developers use is how fast do I get a turnaround?
Yeah.
And especially on the first CI build.
Mm-hmm.
The second CI build where you may deploy to dev or QA, you know, if you've got 10 teams building 20 different services,
mm-hmm.
and they all want to deploy every time they deploy, you got a thrashing situation, and
yeah.
so you have to manage that up front.
Pretty much. The thing is that if you're telling the developers, you know what, I'm actually deploying, if the time you're using on CI to tell the developers this is the build time includes deployment, that's going to vary and that's going to be different every single time because it depends on the server how fast actually process the resources. If you're just telling the guys here, you know what, your build time is from the moment you actually push the code into the moment I actually created a package, that is now depending on the build server.
Right.
So I mean, so it's a little bit more difficult as soon as you start pushing things into infra.
The build time is how they get their feedback.
Yeah.
And wherever it's, you know, the build broke, they get that fast.
Mm-hmm. The only thing that I'm saying is that right now you're not actually taking care of only their code. You're adding also the infra as the code. So that might take a little bit more time because it's something that you need to go over and teach everybody else how it's going to work from now. So we're on version 6, which is right here, where, where the Puppet Masters goes over and tells the environment, pulls everything from the repo, deploy all the packages. I mean, you already know pretty much everything about that one. And after that, you just can, if you have multiple environments, run your testing framework, or if the build server is running the testing framework, or whatever, and then it's just rinse and repeat over and over and over. So with Puppet, using it this way, and if you're able to use cloud provisioners or something else, let's say you have Foreman and you tell the build server, go and deploy the whole environment, or you have some automated way of actually putting in place, let's say. Foreman works pretty well with physical servers. If you have something else that is going to work just like with VMware ESXi, go over and deploy this bunch of VMs, or if you're using AWS. With Puppet, you're stopping into the point of, you know what, from continuous integration, I'm no longer deploying just the application. I'm deploying the whole environment, which means that you can take it to the point where every single commit generates a new environment, a new cloud environment for that specific commit, where you can actually go ahead and test it. The only difference is that now, once you pass it over from development and you merge the Puppet code into production, I mean into stage and then into production, you're pretty sure that it's going to be really difficult you miss something or that there was some error in there, because it's exactly the same physical configuration or resource configurations that you're pushing over from one environment into another. I have some more examples here. Let me just go and grab it. So let me just show you a really quick example of the recursive stuff. So this is just a run deck module that I wrote a while ago, even though I committed later. Here, manifests. Do I still have internet? Oh yeah. So as you can see here, manifest. This is the only thing that you need to go and pass over. The class with all the parameters. You can go and set up hierarchy to pull the parameters out of there. If you're using the way old version of just no definitions, you can pass it over the class and deploy the no definitions. But as you can see here, it goes into operating system. And if it is Red Hat CentOS, require Red Hat service. If it is Ubuntu, require the other type of service. And that one's pretty much, I hate using two screens. Let's put it on Red Hat service. Red Hat service, the only thing that it does is ensure that the run deck is running. However, it's going to go first for the post config. You go into post config, and well, basically, if there's any post configuration options, you can just drop it in there. And before actually doing that, it will call the config. You go back. I know it's a lot of files, but it actually allows you to see. Once you have a lot of different modules, it will be simple for you to actually just keep track of it. So here, the config will set up all your configuration things.
Can you zoom in? Can you zoom?
Oh.
I can't read any of that.
How about that?
Much better.
So the config calls the install, and we're going to go back to the install now. Where's the mouse? Okay, here it is. So let's start. What I'm doing on the install, just going over deploying the file, the John repo in there if you don't have it, and then install the actual package. Then we'll go back and say, oh, okay, I need to go through config. Which one was it? This one? Config just goes over and makes the run deck directory, set up all the files that are required. You can use templates or you can use files itself. I think there's a sample of a file. No, I'm using templates. Oh, okay, anyway. Then jumps into the post config, which is not doing anything. And then jumps into service, which is start. So this module goes over and deploys everything for run deck in one run. Not even going multiple runs, just one. Just put it in there, pop it apply, blah. You have your run deck up and running, and after the pop and run is done. So that's one of the benefits of using the recursive way. Let me see if I have another example here. Let me just see here. It's Puppet. Let me see, Jenkins. So let me just put it on here. This is where is it? It's horrible, but let's see if we can fix that. Okay. This is another example of an application that I wrote because I have to do my own Puppet files. So this is a basic Rails apps. Same thing that I said. Just the initial init, basically you just use it to declare like your variables that you're actually putting in place. Then you're going into Red Hat, and you have the same files. Config, install, post config, and service. It uses the same logic. Service calls post config calls config, and then config calls install. So let's start with install. So this is one of the things that I said you shouldn't go over and do it. At that time there wasn't like the gen support on the package type of resources, so I had to put it in place. But as you can see, these are another type of the requires that I mentioned here. In order to deploy the package, make sure that the package X, Y, or Z actually exists. What it means is that if you don't have that package before, we'll go over and put it in place. So you can ask, it will actually try to go over and see where the hell is the package, I need to put it. So what I'm saying is that besides of using the requires, like up here, require common, you can actually use the same type of logic into each of the resources. In this place, I'm using before executing the install race, you have to make sure that your package is in place and that your file is in place. Same thing here, but this time I'm actually making sure that the file opt ruby, which is just the directory, is in place, and then that the exec actually passes over. And then installs passenger, same stuff, install passenger, which is this one, and then make it over. So there's like recursive stuff or dependencies within the same dependencies, not only at the class level, but also at the pretty much the resource level.
Can I just ask a question on that? You had the require exec, didn't you say not to use that?
Yeah, what I say is that like here on these ones, for the gems, the point where I was writing this stuff, the gem provider wasn't working pretty much well.
Okay.
So I had to just come up with something else to be able to deploy gems. Right now, the package provider allows you to install apt, gem, gems, pip, and I think there's another bunch of different things that you can go over and set up. But that's pretty much, this is kind of like an old code. Let me just go back here into add config. So then again, just going over and deploying files, a bunch of templates. So why put out post config? Because there's some times where you need to go and just run, like for instance, on this case, you need to run bundle install to deploy a Rails app that basically pulls down all your repositories or all your gems from the gem file and we'll go ahead and put it in place. So it's just another placeholder to do different stuff that it doesn't actually mean that you're installing or configuring or doing something else in specific. And the last one, which is service, just make sure it's running. And that's pretty much it. If you follow up this way of coding, I mean, I know that it doesn't follow up the same way that Puppet Force is doing it, but you can actually use the same. I mean, Puppet Force is just deploying modules. This is the technical that you use when you want to define your application. So in other words, you go over and say, I need the Puppet Forge module of Apache, and I need this other one, and this other one, this other one. Then you can go ahead and write your application in Puppet pretty much in this way, and you'll actually be able to pull it off into really quick, no time, and just one run. So let me just go back here. Infrastructure scope, Puppet CI. So like I said, this becomes the actual Puppet kind of a CI environment where you can go over and just keep pushing stuff over and over and over. Your ops team becomes another application development team, not an actual operations teams, which sometimes it actually makes big difference for everybody that is actually in the ops team. And you just keep going and rinse and repeat. And like I said here, any other questions? Yeah.
So if you have something like a war that doesn't have a package provider, should you be wrapping that in an RPM?
Yeah, most of the times this is the easiest way to go over, especially if you're deploying into some type of a Rail, Debian type of thing. It will make things way easier. The reason why is because if you create the package, you can tell the package to take care of all the dependencies of the file, permissions of the file, and that's going to help a lot, but a lot of reducing your Puppet code. As you saw in that environment, I was actually using, like, instead of saying deploying this my application.rpm or something like that, I was using Puppet to every single step. So I had to define all the configuration files, set up the permissions for each of the configuration files and all that kind of stuff. Yeah. That should really go into the package manager because that's what it's for.
Okay. One other question. For the integration with the build server, are you basically pointing a build server like Jenkins at a Git repo that none of the Puppet servers are pointing at? And then do you just have Jenkins have a command that does a Puppet apply in order to test it and then promote it into a different Git branch or repo once it succeeds?
Yeah, pretty much what it's doing is that you have the Puppet master listening to, let's say, the repository where you have production only, or where you have stage only, but all the dev and all that kind of stuff gets pushed into a separate repo. Then the build server will go grab that thing, pass all the tests with no up and the parser, and it passes, then merge it into the other repositories. At that moment, if you want to keep doing like continuous deployment type of thing, and you're really brave, you're going to go over and make sure that the application is not doing any crazy to come up. You can go ahead and just let the Puppet masters pull down the latest, like seriously just git pull from the specific branch, and we'll go over, pull the things, and start deploying right away. Okay. Any other questions?
Yeah. In your experience, is there any use when doing that to run the tests also, or to make test pictures?
The Puppet test is, I mean, it works, but at the end, in my personal experience, I haven't used it that much, because I'm using the simulate as another type of test. So the simulate will give you like every single error saying, you know what, this resource you're trying to install depends on this other one that doesn't exist. So it's a little bit a different way of seeing it. It's more like just driven development kind of way than actually use the writing test for it.
Your variable scope in your configuration files, do they work through all of those, or is it only within that file that variable can be used?
The ones that you define within the class will work under that class only. The only thing that I'm doing here is that, let me just pull the, oh, there it is. Where am I? I lost the mouse now. Okay. So let me just go over here in config, for instance. So what I'm doing here is that the initial class, the init.pp that has the main class, has defined all these variables in there. So I can just go over and call it from any other classes by reference to the initial class. That's how I'm just passing over things. So if you go over and check it out at the, let me just show you the unit. There they are, the actual things in there. When you go over and just call it from the other one, you just need to make sure you're passing the name of the class, colon, and then everything else. Any other questions? No? Okay, good. Well, thank you very much.